And so this is how we have this set up and what we plan to do. And so let's start right over here in this corner, because that's where those two kinds of water were coming in. And so what you have, those two pipes we saw, secondary and tertiary, were coming in from the outside. And right behind here are a couple of pumps. So they will pull the water in, and the pumps are managed from those two boxes there. So we can regulate the power and all. And we have a couple of meters and initial water quality tests that we do as soon as the water gets here. So these are turbidimeters, and we're actually going to be using a handheld turbidimeter later. We'll show you how it works. And this turbidimeters basically tell you how clear the water is, because it's testing, it's flashing light through the water column and then seeing how much of it diffracts. And the more that diffracts, that cloudier the water is. And so the requirement for drinking water is you have to have 0 units of turbidity. And it's a really interesting unit. It's an NTU. Naphthalometric turbidity unit. And so if you have 0 NTUs, that's drinking water. If it's up in the hundreds, it's just clearly, well, it's murky water. It's clearly murky. It's obviously murky. And you can see here, even with the water that's remaining in these columns, you can see that there was a lot of turbidity coming in the secondary, and the tertiary was clearer. And then we do some other testing up on top, and we record these two units, keep a record of what's flowing through, so we have real-time metering. And then it comes out the top and turns right and starts flowing along this wall. And what you have here are a series of basically bays where we can do experiments. And so we have 1, 2, 3, 4 individual bays, and we can, and as we've done here, we've plumbed this out to a tank right here. And every bay, we can do some kind of experiment. And we have some things in planning right now, which I'll tell you about. We have a 5th bay that's stubbed right here, but it's not, it's just the pipes are sealed off for now. So one of the core things that we plan on doing, and you'll see we have some of it already, and we're going to fill in the rest as we get the funding for it, is we're going to take the secondary and tertiary water, bring it out into a tank just like this, and then we're going to put it through all the steps that they're doing over there, and we're going to try to find ways to do what they're doing cheaper. And so we're going to have small-scale units of what we'll see over here. And we have, in fact, we can turn and go over to this unit. This is the reverse osmosis unit. And so we already have that one. Now, remember, reverse osmosis is passing water under high pressure through a really fine filter system. And in order to get the water through that filter system, and the pore size is so small, H2Os can get through, but hardly anything else. To do that, you have to really pressurize the water. And in fact, just to make that point more finely, the membrane size of what is most efficient these days is about 40 times the width of a water molecule. And so if you imagine it really on large scale, that water molecule has to be pushed through like a tunnel that's 40 times its own width. And so that what's happening technologically now is they're trying to find thinner membranes that are still reliable. And that's why something called carbon nanofibers, that's that for many years has been the most promising technology. It's just they haven't gotten it yet to the point where it actually is going to work well. And we're actually going to be doing some carbon fiber, nanofiber testing here at Water Lab in January and beyond. And so, but for now, in order to push that water through, it has to be super pressurized. And so that's why you have these big metal cylinders, is because they're pressurizing there are inside of these long, thin filters, and the whole, and you see these really heavy, the metal pipes and these metal fittings at the end of pipes. It's because this gets pressurized much higher than like a bicycle racing tire. If any of you have been in bicycles where you press against the tire, it's hard as a rock. And that's how pressurized it is. This is more than that, not a lot more than that. But that's why you have all of this pressure, and that enables the water to get forced through those filters. And then you need, in order to do that, you need a big, strong pump, and here it is. Because what you do with all kinds of filters in water treatment plants is the worst water is coming in on this side, it's getting to some kind of filter, it's passing through the filter, the better water's here. Well, whatever the extra stuff is building up against the filter and weakening its ability to do its job. And so almost all filtration systems have what's called a backwash system. And we'll hear it and hopefully see it when we go over to the tertiary system. And it's basically reversing the system. And so you put certain cleaning chemicals and just fresh, clean water in here, and from time to time you shut it down and you run the water backwards, and the system is designed to catch that water and take what's now the effluent from the backwashing, and that gets itself processed. Now, the reason we put Water Lab here and not on campus is that you need water quality permits to do all this. And the city of Watsonville has all those permits, and they let us take whatever wastewater or effluent we produce here, and we just send it to the entrance point to the wastewater treatment plant. And so we didn't need any of those permits because we're just covered by the permit of the whole water treatment plant. So it's very nice. The one thing we can't do, we intend to make drinkable water, but the only thing we can't do is actually drink it. We can admire it, we can swirl it in the glass, we can run it under our noses, then we pour it out and it goes back to the headworks of the wastewater treatment plant. And so that's, and we intend to demonstrate, and one thing that's exciting to me is that students have been involved every step of the way with this facility, and we'll be able to say that students built and designed, built, operated under Eli Weintraub's guidance, a water treatment plant that takes urban wastewater and turns it into drinking water.